Hi, I'm James Lowe.
And I'm Justine Murphy, and this is Light Matters for July 16th, 2014.
On this week's show, a new process combines laser and arc welding, glass lens flexibility to organic photovoltaics, nanojuice aids intestinal imaging, and a metamaterial mirror doubles light frequency.
A new hybrid laser welding technique could reduce processing time and costs associated with manufacturing tanks and pipelines for liquid gas. Developed at Laser Zentrum Hanover in Germany, the approach teams a 16 kilowatt solid-state disc laser with two gas metal arc welding torches. The laser and torch processes stabilize one another, the company says. The torches melt a layer of filler material which absorbs energy from the laser and transfers it into the weld area between the two metal sheets. The company says the process can be used to make single-sided, zero-defect welds for aluminum sheets up to 12 millimeters thick at speeds up to 6 meters per minute. Steel sheets up to 23 millimeters thick can be welded at 1.5 meters per minute, which the company says is 12 times faster than conventional processes. The new system's seam geometry is very narrow and filler material consumption is considerably lower compared to arc welding processes. It also generates less heat, thereby reducing component distortion.
A new carrier substrate made from flexible 100-micron thin layers of glass better protects organic solar modules and could simplify their manufacture. A team from the Fraunhofer Institute of Applied Polymer Research is developing methods for embedding organic solar modules in the flexible glass, which was developed by Corning Inc. and tolerates process temperatures up to 400 degrees Celsius. Organic solar modules can be manufactured with printing technology, which is faster and more efficient than methods used to produce inorganic silicon cells, the researchers say. The thin glass layers are extremely strong, fracture-resistant, and flexible, allowing them to be gently bowed even in solid form. So far, the researchers have been creating their solar cells sheet by sheet. Next, they plan to manufacture the modules in rolls, similar to newsprint. Once the technology is modified for industrial use, the researchers say it could be used in tiny solar cells in mobile phones and large-scale photovoltaic modules.
A cocktail of fluorescent dyes and nanoparticles could aid in the diagnosis of gastrointestinal ailments. Researchers at the University of Buffalo say their nanojuice enables detailed images of the small intestines in mice when used in concert with photoacoustic tomography. Photoacoustic tomography could have advantages over existing approaches to intestinal imaging. X-rays are not safe for repeated use, MRIs are expensive, and ultrasound does not provide adequate contrast, according to the Buffalo researchers. Additionally, none of them provide real-time imaging. The researchers worked with a family of near-infrared fluorescent dyes called naphthylcyanines. To make them suitable for ingestion, the researchers encased the dyes in nanoparticles that disperse in liquid and move safely through the digestive tract without being absorbed into the blood. The research was published in Nature Nanotechnology.
A nanostructure engineered by researchers from Texas and Germany produces nonlinear effects 1,000,000 times greater than traditional macro-scale nonlinear crystals. This Metamirror could enable miniaturized laser systems and enhance chemical sensing, explosive detection, and biomedical research. Part of the mirror is a 400 nanometer thick semiconductor structure made up of about 100 alternating layers of indium gallium arsenide and aluminum indium arsenide, grown by molecular beam epitaxy at the Technical University of Munich. A layer of gold lines the back face of the semiconductor nanostructure, and the front is covered with a plasmonic metasurface of asymmetric gold nanocrosses manufactured at the University of Texas at Austin. The researchers demonstrated conversion of an 8-micron beam into a 4-micron beam, but said their device could be tailored to work across wavelengths from the near-infrared to the terahertz. Besides frequency doubling, the device could also be used for sum or difference frequency generation and 4-wave mixing, the researchers say. The work was published in Nature.
That's it for this edition of Light Matters.
Email us with your questions or comments at lightmatters@photonics.com. And don't forget to follow us on Facebook and Twitter for news updates every day.
Thanks for joining us. We'll see you next time.